surface area. It's a function that I need to minimize. So let's look again. How do we find the surface area? So imagine that this is my container. It has a length, it has a width, and it has a height. Length, width, height. I want to find its surface area, and there is no lid. The lid is missing. It says open waste dumpster. So how do I find the surface area of this? I have two pieces of this, same. I have two pieces, two areas of this, same. And I have one at the bottom. So two on the side, front and back, and one at the bottom. Can anyone give us the surface area? Let's call it S. Can anyone give us the area of the base?
Two x times x.
Very good, awesome. Plus, can anyone give us these areas? 2. Can anyone give us this area? Because there are 2, I already put the 2 in front. Can anyone give us this area?
2xh.
Yes. Plus, now we want the front one. Also 2, front and back. This area.
2x.
So it's the base times the height.
Okay. 2x plus 2 times 2.
Base times height. The height is h. Yes.
Or h, actually.
Good. Awesome. Good. We are close. We have to simplify this and then find its minimum. Awesome. Moving on. So let's clean it up. So we have s equals 2x squared. This is plus 2xh plus, but this is 4. 2 times 2 times x times h is 4xh. These can be combined. Can anyone combine these two and tell us what to write?
6xh.
Good. So I have a problem. And the problem is that this function has x in it, but also h. H must go. Well, I can't erase it. I have this equation from which I can find h and then plug it in.
The quadratic equation.
So can anyone solve this for h? Since we're solving for h, it's linear. We're not solving for x. We're solving for h.
Would it be 6x squared?
6 over.
Or 6 over x squared?
Is that clear, everyone? Is it clear why it's 6 over x squared?
Could we solve it?
Yes, we divided both sides by x squared to solve for h. Is that okay?
Oh yeah, easy, my fault.
No worries. Okay, so now I will replace this h by what?
6 over x squared.
And excellent. And now I can really say that this is a function of x. I could not say it here because I had two variables in it. So then I have 2x squared plus 6x times 6 over x squared. This was the original h. Yes, we're going to simplify 1x from the top with an x from the denominator. And finally, we have 2x squared plus 6 times 6, 36 over x. So now, after all this effort, look, we finally have a surface area. Now we want to find its minimum. What do I do to find the minimum of a function? What are my steps?
Does it find a derivative?
Excellent, very good, awesome. Can anyone help with the derivative?
The first piece is 4x.
Excellent. Now be very careful because we have 36 over x. So it's 36 times 1 over x, and we made it very clear a long time ago how to differentiate this. Anyone remembers what is 1 over x prime equal to? It's
Negative 1 over x squared.
Brilliant. Thank you very much, Levi. Thank you. So then this is minus 36 over x squared. Good. Now I need the least common denominator because I cannot set it equal to 0 like that. I mean, I could, but we can because there are only two terms. Otherwise, if there are 3 terms, I can't. But with 2 terms, we can go ahead and just write s prime of x equals 0 and s prime of x being undefined. Undefined cannot be because when x is 0, the width is 0, the length is 0, I don't have a container. So that's not possible. Okay, so if we set it equal to 0, then we have 4x minus 36 over x squared equals 0. I move one term to the other side and then cross multiply. Cross multiply, I get 4x to the third equals 36. Good. So I'll simplify dividing both sides by 4, and I get that x cubed equals 9. And now, what do I need to do to find x? What should I do to both sides to find x? Anyone?
Find the cube root.
Very good. We apply the cube root to both sides. So then x equals the cube root of 9. Does this give a max or a min?
You have to plug it back into the original equation.
No. We have to find the sign of s prime of x. We don't know if this gives a max or a min. We will after we study the sign of s prime. We will know exactly whether it's a max or a min. Finding the max or the min, you're correct. Absolutely. We have to plug it back in to find it. But I don't know if this is a max or a min. Who knows? Nobody knows. But we will know in a minute. Good. So back to our s prime. Let's plug in. The cube root of 9 is 1 something. So I'm going to plug in 1 to check the sign. 4 minus 36. When we plug in 1, just to study the sign right here, and I plugged in 1. 4 minus 36, is it positive or negative?
It's negative.
Very good, awesome. And let's plug in 10. 40 minus 36 over 100, which is 0.36. So it will be 40 minus 0.36. Positive or negative?
Positive.
That's it. So now there is no discussion. I know exactly what this gives. The cube root of 9 will definitely give what?
A minimum.
Very good. What is the minimum? Awesome. I have to go back and plug in the original function, which is this. So s of the cube root of 9 will be the minimum. So s of the cube root of 9 is 2 times the cube root of 9 squared plus 36 over the cube root of 9. And since I have no idea what that is, we were not asked to find the minimum, but that's fine since we're here. So 2 times the cube root of 9 squared. So 9 to 2/3. 9 and the power is 2/3. And then plus 36 and divided by the cube root of 9. So 9 to power 1/3. Okay, so it's 26 25.96. What is the measurement unit? 25.96 what? We're talking about the surface area. What could be the measurement unit? Remember, the volume was given to us in cubic yards. We are talking about the surface area now.
Yard squared.
Very good, awesome. Indeed, yards squared. So we were really asked to find the length, width, and height. Okay, so this was, where is my graph? So this is x. So this is the width. Width. X equals the cube root of 9. Length. 2 times this. Length. If you want y, is 2 times x, which is 2, the cube root of 9, and of course this is yards. And height. I didn't calculate the height. Here it is. 6 over this squared. So the height equals 6 over the cube root of 9 squared. So these are the dimensions that give a minimum surface area, and that minimum surface area is 25.96. And yes, we have to approximate all these to see what they are. I can't just say the cube root of 9. So I'm going to calculate all of them. So 9 to power 1/3. Then this one times 2. So I'm going to copy, the first one is 2.08 yards, 4.16 yards, and now I have to find the height, which is 6 divided by the cube root of 9, 9 to 1/3. As you see, I'm very faithful to my parentheses, squared. Good. So this is the height, 1.39. Yes, this was a long problem. We had to go through a lot of steps, and let's review the steps one more time. I have a figure where I identify everything I need. I am told the volume is this. I have to think of the formula for the volume, which is for a rectangular solid, the length times the width times the height. So we wrote that. It was given to us that the volume has to be 12. We determined the relationship between x and h. X squared times h equals 6. We eventually needed to solve this equation for h, dividing both sides by x squared, 6 over x squared. We created the function called the surface area. The area of the base plus 2 the sides plus 2 other sides, and simplified. We realized that we cannot differentiate because we have 2 variables. Later on in chapter 6, we will be able to differentiate, but not right now. We don't know how to differentiate a function of 2 variables. So something had to help us eliminate this, and we did. We eliminated by replacing it by 6 over x squared. We further simplified. Now we were in possession of the function. In order to find its minimum, we had to go through the same steps all over again. The derivative, set it equal to 0. We solved. We found x. We put in the table to see exactly what it gives. We don't know what it gives. Plugging in, yes, it's going to give us this number, but we don't know what it is before we study the sign of the derivative. Once we did, we realized that it was a minimum. This is what we studied. This is the culmination, the tip of what we studied in chapter 3. Okay, do we feel like looking at another situation?
Yes.
Good. So let's look at some maximizing profit. How is that?
Good.
Okay, very good. So let's look at 31. Which page am I on? I think I'm on page 5, yes. And that's on page 329 also. Okay. Maximizing profit. Riverside Appliances is marketing a new convection oven. Okay. It determines that in order to sell X, so X is number of units, always take notes. X is number of units, the price per oven, so P equals 280 minus 0.4X. So it's in dollars per unit. Okay. It also determines that the total cost, okay, total cost, 5,000 plus 0.6x squared. Fine. Find the total revenue. That's our first question. So we want to find the total revenue in part A. What is the formula for the revenue? This is not the profit, but the revenue. So price times number of units. How do we write this? Anyone?
Will that be 280 minus 0.4x and then times x?
That's it. So x, 280 minus 0.4x. I will distribute 280x minus 0.4x squared. And you know, I like to present it in descending order, 0.6x squared plus 5,000 and negative 0.4x squared plus 280x. Brilliant. Thank you. Good. Part B. Find the total profit. Okay. How do we find the total profit?
Is it revenue minus total cost?
Very good. Awesome. I have the revenue, negative 0.4x squared plus 280x. Now careful, this negative sign has to be distributed to both terms. Do not just distribute it to the first. It has to be distributed to both. So how do I write that?
It's going to be negative, and then we open brackets and put 0.6x squared plus 5,000.
Very good. Okay. I did it in one step. Yes, that's perfect. Okay. So now let's combine like terms. These are alone, but these two can be combined. What do I get when I combine these two?
It's going to be negative 1x squared.
Very good. Plus 280x and minus 5,000. Part B is done. Very good. Stop me if you have any questions, please. How many convection ovens must be produced and sold, of course, in order to maximize profit? So in part C, we want to maximize profit. What do I need to do in order, what are the steps for maximizing profit? What do we need to do first to maximize profit?
Find the derivative.
Very good, awesome. Can anyone find a derivative for p prime of x for us?
Well, that will be negative 2x plus 280.
Good. What is the next step after we find the derivative?
Equal to 0 and undefined.
Very good. So p prime of x equals 0. P prime of x is undefined. This is a linear function. That's not possible. So we have negative 2x minus plus 280 equals 0, or negative 2x equals negative 280. And how much is x?
140.
Very good. Measurement unit? Units, right? Does this give a max or a min? Who knows?
You have to study the sign.
Brilliant. Thank you very much. So p prime of x, you can say, well, I know it's quadratic and it has a negative leading coefficient. True, but this is what we did in algebra. Now we have a powerful tool, which is the derivative. So 0, 140, infinity, which is not possible, but you know what I mean. So let's study the sign. So in the derivative, plug in 0 and plug in 200. I just need the sign.
Is that gonna be positive?
But when we plug in 0, it's going to be positive. Very good. And when we plug in 200,
It's going to be negative.
good. So what does this specifically tell us? This or this?
So it's a max.
Very good. It is a max. So if we manufacture 140 units, and not below, not 139 and not 141, exactly 140, we get a maximum profit. Good. What is the maximum profit? Let's see, I don't know if that's what they're asking us next. What is the maximum profit? It makes sense. So how do I determine the maximum profit? That would be P of 140.